All right, let's get ready for this test. Okay, bullet point number 1, you need to be able to calculate speed, which are symbols of V. So sometimes we say velocity, even though we know those are different. And centripetal acceleration for an object moving in a circle. So centripetal acceleration equals v squared over r. That r is the radius of the motion. That's on your formula sheet. You don't have to memorize it. V equals a lot of things. Most of these are not on your formula sheet, and you do have to memorize them. First up, velocity is change in distance over time. Okay, so when we're talking about a circle, we're talking about going one full circle. Okay, so that distance, that's a circumference. So circumference is 2 pi r. Circumference is weirdly on your formula sheet. Over capital T for time period. Most teachers just say period, but I say time period, so we remember that it starts with a T. Your formula sheet also says that the time period is 1 over the frequency. So we can rearrange this to say that velocity also equals 2 pi r times the frequency, if they happen to give it to you that way. But that's where these came from, if you were curious. So we needed to be able to determine the direction of velocity, acceleration, net force, or a specific force. Okay. First of all, when we're in a circle, and we have some forces. Centripetal force is never its own random force that you can label. It's always mg down. Maybe a normal force is also pushing down. Or maybe we're over here and we have I don't know, friction. Any one of those could be the centripetal force. Alright? Centripetal just means center seeking. Center seeking. It will always point to the center of your circle. Alright, so it's always the center seeking force or forces. Okay, so never draw a free body diagram with a random oh yeah, we have tension, and we have friction, and we have centripetal force. That doesn't make sense. It's like saying we have tension or friction and our down force. It's well, what force is going down though? That's just an adjective. You need to give it its proper name. Okay, so this centripetal acceleration, always perpendicular to the velocity. This velocity that we're talking about up here and over here, this velocity that's in this equation, that's talking about a center-seeking acceleration towards the center, and that velocity will be perpendicular. Okay, perpendicular. That's not an accident. We are talking about right angles, even though we're talking about circles. Okay, it's at a tangent kind of situation, and it's perpendicular. Okay, we'll see some examples. Okay, we want to understand the dynamics, be able to solve force problems. So these will be our roller coasters and our loop-de-loops and our airplanes and our hills and our valleys. Lots of those. Be ready. We've got the Universal Law of Gravitation. So this is big G. Big G is 6.67 times 10 to the negative 11. M1 is the mass of the first thing. M2 is mass of the second thing. The 1 and 2 are just labels. And this is r squared. That's the distance between them. That squared is actually squared. It's not just a label. Okay. Yeah, planets and things. So gravitational force is one of those things that can be our centripetal force. So if you look at these, note that, first of all, this formula is just this formula, right? And the m's cancel out, okay? So the mass of the little thing that's doing the orbiting, let's say we have a star and we have a planet that's rotating around, the mass of the planet cancels out. Or if we have a planet and we have a satellite, okay, the mass of the satellite cancels out. So the mass of whatever's rotating around, that cancels out when we're setting them up like this. And one of those radii cancels out, so we can cancel out the squared and this r. So really, big G times the mass of the big thing over r equals v squared, which is handy to know. In weightlessness, in my class, we call this normal forcelessness. Okay, you still have weight, you still have mg, it's just you don't have a normal force, so you feel weightless, but you're not weightless. Okay, you're just normal forceless. Okay, let's do a few of these. I'm using a free recording software, so my videos can only be 10 minutes long. So we'll see how many we get through. Okay, a hollow tube lies on a thing. Okay, so if we are going around this circle, that means that our acceleration is inward. Centripetal acceleration is center seeking. So the acceleration is always going in. So if we release right here, our acceleration is going in, center seeking, which means our velocity has to be at an exact right angle. Okay, a squared equals, nope, AC equals v squared over r. That v and that a are at a right angle to each other. So the correct answer is C. All right, it is a tangent path. Yeah, I got it right. I should have checked the answer key before I plowed through these. We were plowing away anyway. Okay, so we want to rank the centripetal accelerations. Well, AC equals v squared over r. So this one's just v squared over r. This one's 2v, so that's 2v squared over r. So that's 4v squared over r. So that one will have 4 times the centripetal acceleration as this one does. So b's got to be more than a already. Let's see, does that eliminate any? No, they all said b was more than a. We've learned nothing. Okay, same v, same r. It doesn't matter that they're in different directions. V squared over r. So a equals c. Does anyone doesn't have a equals c? A equals c. Oop, not that one. A equals c. Good. A equals, that has a typo. That's not looking good. A equals c. Does it also equal e? Maybe. Okay. D. So this is v squared over 2r. Also known as 1/2 v squared over r. So far we've got d, oh, the smallest. And then we got a equals c. And b is the biggest so far. We've got to figure out what e equals. So this is 2v squared over 2r. So that's 4v squared over 2r. Also known as 2v squared over r. So we got 4v squared over r, then 2v squared over r, so e actually goes in right here. And then v squared over r for a and c, and then half of v squared over r for d. So we got b, and then, no, they don't equal each other though. Only one equal sign. What do we got 2? C and e, those do not equal each other, that's not true. B bigger than e, bigger than a, which equals c, bigger than d. I like this one. Right, because if we were going to write them out, our problem still had to go slow motion. So b is 4v squared over r. E is 2v squared over r. A and c are just v squared over r. And d is 1/2 v squared over r. So that's what's going on there. Do I have time for another? I think I do. Maybe. Okay, a coin is rotating. This was a free response question on the AP1 test one year. At the instant, what's the coin's velocity? Okay. So our acceleration is center seeking. So if it asks for the acceleration, that'd be d. So if that's our acceleration, our center seeking centripetal acceleration, that means a's got to be our velocity. A is our velocity. It's got to be a right angle. Yeah. Okay. And then we're wondering what's the friction. Ooh. Okay. So the friction force is our centripetal force. Okay. Our centripetal, yeah, it's our centripetal force. Okay. So that's what's holding the coin in. Imagine if it was if there's no friction, if it was really slidey, if it was ice and something slick and you started rotating, where would it go? It would slide to the outside. It would fall off. It would slide out. Okay. So the motion with no friction is B, which means friction's got to oppose that, which means friction's D. Okay, that's how I have to think through these friction ones. Okay, yeah, that's a good stopping place. How many more? 1, 2, yeah, no, that's a good stopping place.